The combustion of the gummy bear is one of the fascinating demonstrations and fits right into the whole discussion of pyrotechnics. Basically, the key components in pyrotechnics are a fuel and an oxidizer. And one of the major oxidizers used in pyrotechnic formula today is potassium chlorate or potassium perchlorate. And in this case, we oftentimes use sodium chlorate. And the reason for that is because it's a little easier to melt. It's got a lower melting temperature. And that's the key to getting the reaction started. Once the chlorate is at a molten state, it now has enough inherent energy and temperature that the reaction will spontaneously take off. And so in a molten state, when you add the fuel, in this case the gummy bear, which is a sugar, carbohydrate, to that, it auto-ignites and takes off and combusts and burns. You can do this with wood. You can do this with other types of candies, small pieces of candy, M&Ms, things like that. Just adding them to that molten chlorate will cause them to ignite and burn and combust. Produces an interesting odor, the smell of like burnt sugar, which is kind of pleasing compared to some of the heavy organic smells sometimes you get in the chemistry lab. And you see the reaction conclude and burn up with the end of the flame going out, and the reaction finishes up. The interesting thing is for us that do the demonstration many times is that the tubes do survive it. It's a rigorous reaction, a lot of heat, intense heat, very fast, but the tubes do survive it, and usually we can do them several times, but finally then it fractures the glass enough, heats it up to the point that then we can't reuse it, and that's one of the safety factors that we have to be aware of. If you use a fractured glass or something that has hairline cracks in it, when that heats up, that sudden rise of temperature, we know from use of glass, it'll cause the glass to break. And so that's why all the shields are around this, not because there's any potential explosion, but just we know we're stressing that glass to its breaking point or close to it, and so if that would break and fall, then the glass isn't going to bounce all over, it's going to stay back there. And I've not ever had a tube break on us over the years that we've done it, but we rigorously check them, and once they get to the point that there any kind of crack in them, then the tube's dispensed of, and we use another one. These are also known as combustion tubes. So they are composed of a glass that's made to deal with heat stress, and we do what we can to help prevent some of the stress. As you see, the tube's heated so that the chlorate goes to a molten state. So the tube's already warmed up a little bit because of that heating process, but then when it auto-ignites, that jumps up very rapidly in temperature and then burns intensely to the point of consuming all the reactants, and so the tube still takes a lot of stress. Safety requirements on this one would be that you need to shield it, just because the potential that tube could overheat and break and just drop down. You want to have a room that has good ventilation. Potentially the best way to do this would be to do it right in front of your hood. If you've got the distance that the glass can stand back away and have this right in front of the bench in front of the hood, then you can have the gases being sucked away and out the hood and that. It does produce a lot of gas. It's kind of a pleasant smell, the burnt sugar, but it is a lot of gas, and so you don't want to do it in a confined space because of the amount of gas produced coming off the reaction. Other safety requirements or points to be aware of, the tube's going to be super hot, so you've got to have it held by something that can handle the heat. You don't want to have it doing with some of the rubber 3-finger clamps and rubber tubing over that. That's going to cause you a real issue. So you want to have it something that can handle the heat and that. We've had methane gas piped into our lecture rooms for years, and I believe that's the way we were able to do this demo, but in other times we had to actually use the little butane canisters, and those work real well to heat. And so if you don't have a heating source in your lab, a butane canister works well to heat it up, and so it's easy to do that way.